Hi everyone, welcome back to the AI language. In today's video, we are diving into something super exciting and futuristic. So we are going to build an A2A agent using Google's brand new agent development kit, also called ADK. If you are curious about how agents can communicate and collaborate seamlessly, this video is your step-by-step starting point. So before I begin, let's take a quick look at what we'll be building today. The A2A agent-to-agent protocol is more powerful and slightly more complex than the traditional model context protocol that some of you might have worked on. So it's very important to grasp how these components work together because that's the secret to building scalable A2A agents. So we'll cover 4 key components, and to show you that I have the folder structure over here for our particular A2A agent using the Google ADK. So here are the 4 key components. This is agents, server, client and app. And then we have some data models which basically help us exchange data between the client and the server side. So the server side is essentially the agents. And over here we have just one agent for now, which is a Google ADK based agent under agent.py. This defines the Gemini powered tell time agent. And then we have a task manager, which is a custom manager that connects the agent with the task. So it basically manages the task logic, invokes the Gemini model and so on. And then we have the server. The server.py file basically launches the A2A server, and it receives and routes the task, and the task manager.py over here is basically just a base class, and this is used to actually then build upon the actual agent task manager over here. So both these together basically are the server side, because you want to run the agent which will then spin up its server and expose itself on the server's URL and port. Then you have the client side. So on the client side, there's the actual client which is going to basically send task requests to A2A agents. This basically connects to the agent, sends requests and fetches the results. Now the cmd.py is basically a command line based interface we use to test and trigger requests. So it's basically an app which is a command line interface to run the client and send tasks to the agent. So these two together form the client side, and as you see, the server, the agent, the client and the app are all modular. So you could have multiple agents and the same server can work with all the agents over here. The agent just needs to spin up its own server and it can use the common code over here. Similarly, you have a client which can basically send tasks to any agent. You just need to specify what agent you want to send to, or you want to have a discovery logic where the client discovers the available agents and then sends the task, which is a more complex matter that we'll actually come to in later videos. And then you have an app. So how do you run the client? How do you interact with it? Is basically through a command line interface over here, which is the cmd.py file. Otherwise, you can actually have a visual interface like we did for our MCP code. We built a Streamlit UI. We can do multiple kinds of apps that use the same client, server and agents over here. Finally, we have the models, and these models basically define several aspects of how data is structured to communicate between these components. So agent.py defines the agent card and agent skills. JSON_RPC.py is basically the base class for JSON-RPC protocol, which is a remote procedure calling protocol. The request.py file basically handles task and metadata request types. And the task.py file is the core task structure and status tracking. First, we'll build an A2A server and our agent. We start the A2A server and our agent in a terminal window. So basically we run the agent and the server then spins up and it's ready to listen for incoming tasks from any client on this particular host link. Then in a separate terminal window, we start the command line client using a simple Python script. So we make a command line host or an app for our client, and we provided the agent's server URL over here, and then we start this. Now what's happening over here is that the client fetches the agent's metadata, and then it basically asks us to write a query that we want to send to the agent. So we are going to write the query, what time is it, as we want to know that from our agent. And now as you can see that the client basically sends a JSON-RPC request. So RPC stands for remote procedure call, and over here we have the method which is task/send, which is used to send a task. We have an ID for the task, which is over here. We have a session ID that our host app basically manages. Then we have a message from the user which has parts, and this is basically a text part which says what time is it. And then there are some other properties which we are not using for now. And then we get a response from the agent which says the time is, and then we have the time over here. So what we have done essentially is built an app which is a command line based app that basically communicates with the client, and that sends a task to a server which then communicates with the agent to get the task done and sends a response. The agent uses Google's ADK agent framework to build an agent using the Gemini API. Alright, so before we start understanding this particular A2A agent made with Google ADK, I just would want to iterate that there's a playlist that I have made which is the full course on agent to agent protocol or A2A, and it has multiple videos that we are going to make and add to this playlist. There are already 2 videos which you might have looked at already. If you have not, please do have a look at this. The first video, A2A protocol complete overview, it gives you an overview of all the components and how they connect together and how does information flow through them. There's also an aspect of the life cycle, that is how does the A2A client discover the A2A server, how does the processing happen, and how does the completion, interaction, etc. happen, which are basically all pointing to the life cycle of the A2A protocol communication. The second video is on building an A2A client and server, which is a very minimal Python implementation that just uses agent cards and task/send, which is to introduce A2A based coding of clients and servers to you. So do have a look at these 2 videos. And now I'm going to add the third video over here, which is the next part in this course, where we actually use a Google ADK based agent that uses the Gemini API for its large language model, and then it interacts with basically your client to answer queries. So now that we understand how everything is structured, let's walk through the code that powers all of this. So let's start from the agent and the server side. So we have an agents folder which has a subfolder for the Google ADK based agents, and the idea is that you can actually extend this to have as many agents as we want. Each agent has a main driver script which is main.py over here. It has the agent logic and the task handling logic in task manager.py. Let's go through the agent.py file first. This file defines a very simple AI agent. In our case, basically it's called the tell time agent, and it uses Google's ADK or agent development kit and the Gemini model to respond with the current time. So we're basically using these 2. This is our agent framework, and this is the large language model that we're using to build this agent. So first we have all the imports. So an important one over here is the Gemini based AI agent provided by Google's ADK, for which you need to actually install and import Google's ADK libraries. Then we have ADK services for session and memory, for which we actually import these libraries over here. Then we have a runner. So the runner connects the agent, session, memory and files into one complete system, and again it is provided by the agent development kit. Then we have the Gemini compatible types for formatting input and output messages from Google's Gen AI. And finally we have the environment variables like API keys that we load from a .env file. To define the agent, we'll define a class which is called tell time agent, because our agent basically just tells the time. We first define what type of contents does this agent support. So we are just going to say it supports plain text input and output by providing supported content types over here. Then we initialize the tell time agent. It creates the LLM agent which is powered by Gemini, and it sets up session handling, memory and a runner to execute tasks. So we basically call the build agent function that's below, and this sets up the agent. And then we basically use a fixed user ID for simplicity, which is time agent user. Now we basically define the runner, which is basically what actually manages the agent and its environment. So we provide the agent name, which is basically set up during the building process. Then we provide the agent itself, And then we provide some services for files, for keeping track of conversations, and for remembering past messages as history. Then we define the build agent function that's actually going to return the LLM agent, which is a Google ADK agent over here. So it creates and returns a Gemini agent with basic settings. And this is an agent object from Google's ADK. So we just specify the model version that we want to use. We'll provide a name for the agent, we'll provide a description, and we'll provide an instruction for the agent to work for a query. So basically this is the system prompt that we provide. Then we have the invoke function. So this will basically handle a user query and return a response string. So we have the query, which is a string. So what the user has said. So let's say the user says, what time is it? And then we have a session ID, which basically helps group messages into a session, and we are then returning a string which is the agent's reply, usually the current time. So we use the session service where we try to reuse an existing session with this session ID, or we create a new one like so if it does not already exist. Now we define the content or the user message in a format that Gemini expects. So it basically has a role which is user, and it has the parts which is basically the text query. Now we run the agent using the runner and collect the response event. So we provide the user ID, the session ID, and the content for the message. We have a fallback to return an empty string if something went wrong. So if there is no events, or there's no content in the last event, or there's no content part in the event, we return an empty string. Then we extract and join all the text responses into one string. So for all the parts in the last event, we take out all the parts and then we basically join them using a new line character, and that is what we return over here. We also have a stream function, but this is something that I'm still developing, so I'm not going to go into this. This particular agent does not currently support streaming. So this is our entire simple agent, which basically can tell the time, and it connects to Google's Gemini model, and it uses the Google's agent development kit to build the agent. Now let's go to the next file under the agent's Google ADK folder, which is taskmanager.py. And this file is basically the bridge between the agent and the server. It receives the task, gets the user query, invokes the agent, and sends the response back. Alright, so again, this file's purpose is to connect your Gemini powered agent, which is the tell time agent, to the task handling system. So it inherits from the in-memory task manager. This is basically a base class that it inherits from, and it basically will receive a task from the user. It extracts the question. So for example, the query, what time is it? Then it asks the agent to respond, which we have already looked at the agent. So it will use the agent functions that were defined over there, and then it will save and return the agent's answer. So there are basic imports that are there over here, and there's a logging setup that we do over here. And after that, we basically have the task manager. So to have an overall look at this task manager, what you can do is you can actually collapse all the code blocks, and there are basically these three simple functions that are there inside it. The initialization of the task manager, the get user query, which basically extracts the user query from the incoming task, and then the main logic to handle and complete a task, which is on send task. So task manager will basically send the task to the agent and then get the response. So it basically inherits all the logic from the in-memory task manager, which is the base class. It will override the part where we handle a new task, which is on send task. So this is what it overrides and basically then provides it for this particular agent. And then it uses the Gemini agent to generate a response. So let's first look at the initialization logic. So it just stores the Gemini based agent as a property apart from calling the superclass constructor. This is basically how you connect the agent to the task manager. Then we have the next function, get user query. So it will get the user's text input from the request object. So example, if the user says what time is it, we pull that string out. It basically gets a request object, which is a send task request object, and then it returns the actual text that the user asked for. So it basically goes through the request params, and then for the param it basically checks the message, and it takes the first part and then it takes the text for that. And then we have the on send task function. So this is the main logic to handle and complete a task, which is what the task manager is doing. So it does the following: it saves the task into memory or update it. It asks Gemini agent for a reply. Then it formats the reply as a message, and then it saves the agent's reply into the task history, and it returns the updated task to the caller. So it will save the task using the base class helper. It will get what the user asked for using the get user query function. Then it asks the Gemini agent to respond. It uses the invoke function for the agent that we looked at, and it provides the query and it provides the session ID. From the result text, it basically creates an agent message with the role agent and the text part, which is the result text over here. Finally, it updates the task state and adds the message to history, and then it returns a structured response back to the A2A client. So it will basically return send task response object with the request ID and the result. So this is basically your task manager, and again, this basically connects your agent to the task handling system and basically drives the agent. So now we go to the third important file. This file is the main.py file, and this is basically the main script that we are going to run on the terminal to start our tell-time agent server. So we're going to look at the server code, but ultimately this is a script that starts and sets up the agent and the server and basically sets it up to listen at a particular port. So it declares the agent's capabilities and skills. Then it sets up the A2A server with a task manager and agent. So we already looked at task manager and agent. We are going to look at the A2A server next. Then it starts listening on a specified host and port, and this script can be basically run directly from the command line, and this is what we are going to do to run our server. So we import our A2A server, we import all the models that we want, we import our agent and task manager, and essentially this is going to then connect all these together. Let's go to the main function over here. So basically it defines the agent capabilities over here, and we are going to say that this agent cannot do streaming. It does not support streaming. Then it defines the skill this agent offers. So it's basically a skill ID which tells basically that it can tell the time, and there's a human friendly name and description. There's some optional tags, and then there are some example queries. So this is basically what we say is an agent skill object, and this is the skill. Then it basically creates an agent card describing this agent's identity and metadata. So when we run this, we basically then have the agent card available, which then provides the name, description, URL, version, input and output modes that this agent supports, the capabilities and the skills. So this is what is going to be used by clients to discover the agent and understand what all capabilities they have. Then we start the A2A server. So when we are going to run this particular file, it's basically going to define a server with a host, a port, an agent card, and a task manager. The task manager itself takes in the agent over here. So now you see that you have basically provided the agent, then you have provided a task manager which basically uses that agent, and you have provided the agent card, and all of this is basically then provided to the server to create a server object, which we then start. We started by saying server.start, and this basically runs the server. So this is our main.py file, and when we run this, everything on the server side, including the agent and the task manager, starts running. Now let's look at the server. The server itself basically defines a very simple A2A server. It supports receiving task requests via post and letting clients discover the agent's details via get. So there are basically these two routes that it sets up, and it can receive the task on this route. Remember that the task/send is the actual route for receiving a task, but what we do is that we send that as a method name in the parameters inside the request rather than actually provide a path with /task/send. Then we let the clients discover the agent's details via get on the well-known agent.json URL. So let's go through this code. So we have the required import. So Starlet is basically the lightweight web framework that we are using to build our web app. We have used this before in MCP. If you have seen that video where we built a Streamlit UI for our MCP client, and we actually went through this in detail on how Starlet works over here. Then we have our custom models and logic. So this is basically the models that we use to define different data points. So we describe the agent's identity and skills. We have the request models for tasks, where we have the JSON-RPC utilities for structured messaging. And then finally, we have the task manager for our agent. So the server is going to use this task manager to then communicate with the agent. Okay, then we have some other simple imports over here and a JSON serializer. So basically, since we want to format the date type in a particular way, we use this serializer over here inside this server. Over here is our main A2A server class. So this is the core server logic, and let me just collapse all the code blocks over here. So you have the initialization over here, then you have the start, which is basically what starts the server. Then we have the get agent card over here. So this returns the agent's metadata. Then we have the handle request. So this will basically handle all the incoming post requests for tasks from the client. And then we have a create response function that converts the result object to JSON response. So essentially the server is packaging everything and then interacting with the client. It uses the task manager to then basically get the work done from the agent. And it has these basic functionalities to start the server, to get the agent's capabilities, to handle the incoming requests, and to create a response. Let's go through each of these in detail now. So this is a constructor, and basically it defines an IP address to bind the server to. Then it basically defines the port number to listen on. There's a metadata that describes our agent, the name, skills, and capabilities in the agent card. And then we have the task manager, which is basically the logic to handle the task using Gemini agents. Then we initialize the Starlet app over here, and we add the routes over here to handle the incoming requests, to get the agent card on the well-known URL, and to basically handle the incoming tasks on the root URL. Again, just to remind you that the task/send aspect of the incoming task is specified as a method name inside the params. So this is our app, and now we have a web server. So the web server itself is basically built using something called uvcon, and this start function starts that server. So it says uvcon.run. It provides the app that you're going to host on that server. It provides the URL that you're going to provide to that server on which the app is going to expose itself, and it also provides the port in a similar fashion. This is basically running your server, and the app that you're running on this server is the Starlet app, which we defined above. Alright, so next we have the get agent card, and this is basically a simple return for the agent card over here. So then we have the handle request. So this is going to handle the incoming post requests for tasks. So we have a handle request function which receives a request. It passes the incoming JSON, validates the JSON message. For supported task types, it delegates this to the task manager, and then it returns a response or an error. So we pass the incoming JSON body, and we'll also print it. Then we'll validate. So we'll basically parse and validate the request. This A2A request is a model that we use inside the models folder. Then if it's a send task request, so if we basically find that this was a send task request, we call the task manager to handle it. Else we basically raise a value error that that's an unsupported A2A method that has been used, and we basically use the task manager's on send task function, which we have looked at when we were talking about the task manager. Then we convert the result into a proper JSON response using self.createResponse. This function will come in below. So it basically just formats the response in a particular way, and we have some exception handling over here. The create response function that we used above, it basically converts the JSON response object into a JSON HTTP response. So the response object basically is the argument, and a Starlet compatible HTTP response with the JSON body is what it returns. So this is your entire A2A server. So now let's go back to this folder structure, and what we have seen over here is the server that basically encapsulates the task manager for the agent. So task manager then encapsulates the agent and the communication with that. The server delegates the task to the task manager, which basically then gives it to the agent, and then the response flows back to the server. And the main.py file inside the Google ADK folder, which is not shown over here, is the script that starts the server and then sets up the server to work with the task manager and the agent. So this is a complete server side and agent side logic that's happening over here. Now we can look at the client side and app side logic. So inside the client folder, we have the client.py file, And this is the async HTTP client that connects to our server. So it wraps our payload into the expected JSON-RPC format and sends it to the agent. So that's as simple as that. So this file defines a reusable async Python client for interacting with an A2A server. It supports sending the task and receiving responses, getting task status or history, and streaming and cancelling are not supported in this simplified version. So it basically supports sending tasks and receiving responses in this particular version. So here are the basic imports, and then we have the import of all the models that we want. So we want the request model and the JSON-RPC model over here, along with the task and the agent models over here. So we have the send task request model that we'll use in this particular implementation. We also have the JSON-RPC request model. We have the task itself, which we'll use to create the task, and the task send params for the params, and we have the agent card model for the agent card. There's some custom error classes that we have over here, and this is our main A2A client. So let's collapse all the code blocks over here. And so now you can see that it's a pretty simple client. So there's a constructor, there's a way to send a task and get a task. So we're not using this over here right now. And there's an option to send a request, which is basically when you send a task, you use the send request function to actually send that request to the server. So let's look at the constructor first. So the constructor basically just takes in either the agent card or a URL. So what you need to tell the client is what is the server you want to interact with. So over here, this is what we call manual discovery. So we are manually specifying the server that you want the client to interact with. There are also different ways of discovery that we can actually look at, which are more complicated, like where servers will register themselves with a common registry and the client then actually accesses that registry to look at what all servers are there. But in this first step, we are using manual discovery. So we'll actually provide a URL for this. And what we'll do is that since the agent card will not be provided when we run the client, we'll just provide the URL and we'll assign that URL to the client, and that's all that the client needs to know in its constructor. Then we have send task, which is basically going to send a new task to the agent. So it will create a request object, which is a send task request object with a unique ID and params, which are task send params. So this task send params will basically have a payload, and what this will do is that it will basically wrap the payload into a proper model that is needed by send task request. So if you look at task send params, it has an ID, it has a session ID, it has a message, then it has a history length and some metadata that basically we are not using. The payload itself will provide the ID, session ID, message, history length and metadata, and this is the payload that it's going to receive from our app. So the command line app that we are basically going to use will basically send this payload to the send task function over here. Once you create this request object, we basically use the send request function below and we send this request to the agent. We await for a response and then we return the task with the result from the response. So again, we extract just the result field from the response and we create a task object from that response's result and we return that. We're not going to use the get task function over here. We'll get to it in a future video. And finally, we have the send request function. So this function basically is a helper to send a JSON-RPC request. We're basically posting the request to the URL, which is basically the agent's URL. We are taking the request model and converting it to JSON and providing a timeout. And then we are basically getting a response. We check if the response status code is 4xx or 5xx for any errors. And then we basically return the past response as a dictionary. And then we handle some basic exceptions that we created over above in the code. So this is our send request function, which is actually going to send the request, and our send task function uses this function to actually then send the request. So this is our client, and then finally we have the command line interface. So we create an app folder where we can actually have multiple apps that use the same client, server, agent, etc. And what we're going to do over here is we are first going to build a command line based app, which is in cmd.py. So this file is a command line interface that lets users interact with the tell time agent running on an A2A server, and it sends simple text messages like what time is it to the agent, and it waits for a response and displays it in the terminal. So this is actually going to use the A2A client and send the task basically through that A2A client. So we have some basic imports followed by importing the A2A client and basically import the task model so we can handle and parse responses from the agent. We use click.command to turn the function below into a command line command. So basically we can provide an agent parameter with the URL, and this is the base URL of the A2A agent server. So basically when we are using this command line app and we run it, we provide it the agent that the client needs to connect to, and this command line app is just going to help us do that. There are also some other parameters that we have defined for future use like session and history, which we're not going to use over here, but we're going to come to it in a future video. So this is the main definition for the command line interface to send user messages to an A2A agent and display the response. So it basically takes in the agent. So what agent basically are we connecting to? And it basically takes in the agent URL, and it also takes the session and history, which we're not using right now, and we'll come to it in a future video. So first we initialize the client by providing the full post endpoint for sending tasks. So A2A client just takes in the URL. We've already looked at the A2A client class inside the client.py file, and it now knows what agent it needs to connect to. Then we basically provide a session ID. So we define or create a new session ID if it's not provided. Then we prompt the user. We start the main loop and we prompt the user for input. So what do you want to send to the agent? And we provide an option to quit. And if basically the user asks to quit, we break this particular loop and exit. Otherwise, we create the payload. So this is the payload that we have seen in the other file of client.py. And we construct the payload using the expected format for a task. So it has an ID, it has a session ID, and it's composed of messages that we have seen earlier. Then it has a role for each message, and each message is composed of parts. Over here, there's just one part whose type is text, and the text itself is the user prompt. So this is the complete format that we expect. Then we use the client to send the task to the agent. So basically we're using the client's send task function over here, which will ultimately use the send request function to send the request to the A2A server. So it basically sends the task to the agent and gets a structured task response. And if the agent responded, we basically check the task history parameter, and then we basically take the last message and then print out the text from that message first part, which is basically the agent's text reply. We might want to show the conversation history, but again, we're not using this for now. And then we catch some exceptions over here. This is the main entry point for the command line interface to run. And now this basically completes our code for the command line interface. So again, going back to our A2A project structure, you can actually see that you have an agent and a task manager that basically helps run that agent. You have a server that delegates the task to the task manager and exposes itself to the client. You then have the client, which basically will connect with the server to send tasks. And then you have an app over here, which is a command line interface app that basically interfaces the user with the client, receives the query from the user, and then sends it through the client to the server and gets it processed by the agent. To do all this, you also have some models which are there in the agent.py file, JSON-RPC file, request.py file, and task.py file. And now let's quickly look at all these models. So we can actually go through each of these files. I've added actually a lot of comments to each of the model over here so that it's basically self-explanatory and you can understand each of the params. So I'm going to go through one of these models over here just for reference, which is the most important one, which is the agent card model. We have already used this model at several places in the code, and basically it has a name, description, URL, version, capabilities, and skills. This basically provides the core metadata about an agent, and this information can be shared with the directory service or other agents during discovery. And it basically describes what the agent does, where to reach it, and what capabilities it supports. Then you have the JSON-RPC models file, and this has all these models. So you have a model for all messages, a model for a call from one agent to another, the reply to a request, either result or error, which is JSON-RPC response. And then you have the structure of an error response and a predefined standard error for unexpected failures. So you'll find all these models heavily commented out over here, and you can have a look at all these models. So finally, you have the request.py file with all the models related to the requests. that we make. So we have the send task request, which we actually use. We have the A2A request, and we have the send task response. So the send task request basically just has the method, which is task/send, which is defined over here, and then we have the task send params. Then we have the A2A request, which is basically a discriminated union of the supported request types. So it basically allows automatic passing of request types based on the method field. We are just using the send task request for now, and we'll add more requests over here as we go along. Then we have the send task response, and it's basically a response model for a successful task/send request. Just has the result, which is the task returned by the agent. So now we have looked through almost all the files, and there are a few more files which you can actually go through. So for example, the task.py file, again, it's pretty heavily commented, and it's just basic models used to handle all the tasks and sending all the parameters. The other files that you might want to look at are the task manager.py file, and this basically defines how tasks are managed in A2A protocol. And there's a base abstract class called task manager and a simple in-memory task manager that keeps the tasks temporarily in memory, and this is what is used to then build on the agent task manager which we have in this particular folder. So I think that covers all the files that we want. Now let's talk about setting up this code. So the first thing is that please use the URL in the description to check out the code from GitHub. And once you do that, you'll have a folder structure like this. So as discussed, you have agents, you have the app, you have the client, and you have the models and the server. As we build more versions of this, we're actually going to move the old code into the version folders. So for example, right now I have moved the older code to version 1_simple, which was our simple A2A server and client, and version 2 is this particular version. So it has the same code inside this folder as is over here. When we're going to improve version 2 and build a version 3, we're going to add the version 3 code over here, and in case you want to refer to the version 2 code, you can actually look at this particular folder. The next thing is that we are going to set up our environment variables to include a Google API key. So for that, we are going to make a .env file. You can actually go to aistudio.google.com and log in through your Gmail account, and they are going to give you a Gemini API key for free. So there are some terms and conditions that you can check when you take this key, and essentially you can actually use it for free for testing purposes with certain lower limits, and by allowing them to use your data while training their model. And this then makes it an ideal choice for this tutorial and experimentation. So I am on aistudio.google.com, and when I visit this site, it automatically gives me a prompt to get an API key over here. And otherwise, I think there's a button over here also to get the API key. So I'm just going to click on get API key over here. Okay, so there's a code to test the Gemini API, and there's a create API key button over here. So let me just use the API key from here. It's going to now generate the API key for me, and you should use your API keys securely and not share them or embed them in code that the public can view. I'm going to disable this after the tutorial. For now, I'm just going to copy it from here and let it be visible. So to do that, go to your A2A samples folder, which is the folder that you check out from GitHub. Then shift to the version 2 folder, which basically has our ADK agent. Then say touch.env, and this is your environment file. Now go ahead to VS Code, go to the version 2 ADK agent folder, and then locate your .env file. And over here you need to add a Google API key in this format. To add the .env file to git ignore, what you can do is you can go back to the terminal, and inside the version 2 ADK agent folder, you can write touch.gitignore and then use Visual Studio Code to open this file, and then just simply type .env over here and save this file. Alright, so now let's look at how we can run the code. So to run the code, you move to the checked out folder, which is A2A/A2A_samples. So this is the folder that you would have checked out of GitHub. Then you move to the version 2 folder, because the ADK agent is basically our version 2 of the A2A protocol client and server and agents. So we move to this particular folder. Then you basically activate a virtual environment that I've already created over here. So we write source.venv/bin/activate, and now we have this particular virtual environment. Now we can simply type uv pip install -r pyproject.toml. So this is going to install all the packages listed in this file. Let's have a look at that. So we have async click, Google ADK, Google Gen AI, and python.env. To run the agent now, we can type python 3-m agents.google_adk, and this is going to start the agent server and link the task manager and the agent for us. So now you can see that the server is running on this particular URL. Just to demonstrate how to start the client, you can type python 3-m app.cmd.cmd, and this is basically going to start the app, the command line interface, which is then going to interface with the client. We are going to provide the agent URL over here. Let's press enter. And now it says, what do you want to send to the agent, and type :q to exit. So let's type :q and exit for now. This is just to show how to start the agent and the command line interface. To run this, please refer to the demo at the beginning, where you actually start the server in a separate terminal window and the client in a separate terminal window, and then send the queries. Thanks for watching. Please do like the video and subscribe to my channel if you want to learn about MCP and A2A protocol, and I'll see you in the next video.